Alrighty, hey, so as you can read, as you might be familiar, the topic is graphing inequalities. So let's get started. Let's get right to it without much delay. So when we're graphing inequalities, it works very much like graphing anything else. And I guess I'm going to need to go that way so I can get to other tools. But graphing inequalities works just like graphing lines. So we're in slope-intercept form, mx plus b. Remember, with mx plus b, that's M, that's B. B tells me where to begin. M tells me how to move. So I begin at -2. Boom, right there. Okay? And then my slope says 2/3, so I go up 2 and over 3. And honestly, because, these are counting by 2, you might go, okay, up 2 and over 3, but I can just go up 2 boxes, 1, 2, 1, 2, and then over 1, 2, 3 boxes. And it works just the same way because I'm being consistent in the way that I do my rise and my run. So it's not really about counting necessarily the numbers, as long as these scales are equal, as long as I'm going 2 this way and 2 that way, or if it was 5 that way, whatever it is, I get the same slope. Because if you look, if I went up 2 this way and over 1, 2, 3, I'm right in line with where I want to be. So it's easier just to count boxes, up 2, over 3, that gives me my slope. Just like with graphing lines, I'm still going to draw the line. I'm going to try my bestest to make it pass through. I'm pretty good at that. There you go. We still want it to be a double-headed arrow. I'm not going to worry too much about that particular piece. I can add the extra arrow to it. So how is this different from graphing? How do I deal with this part? Well, the way I deal with this part is that this is where we're equal to 2x third, or 2/3 x minus 2. I want to know where we're less than or equal to. So what I do is I say anything down here, anything below my line is part of the answer. So the way we show that is we just do some shading. We shade in below the line. And I always suggest that we shade in using lines that are perpendicular to the line. Okay, instead of just doing a scribbly thing, I shade in that way because, well, if we have systems of inequalities later, it makes it easier to see where they are. It just looks neater, it looks like more of a deal, and they can go as far down to the corner. But the general idea is all of this is part of my answer. Any place in here, y is less than 2/3 of x minus 2. Okay? So we graph the line like we did, and then we deal with the shading. And there's a little table that we'll complete right now about how to deal with a solid line versus a dotted line. And we didn't do any dotted line ones, but if I have something, and this works when I have like in slope-intercept form, if I have y is greater than or equal to whatever's on this side, I'm going to use a solid line, and I'm going to shade above the line. Okay? We just did y is less than or equal to, and so we put in a solid line and we shaded below the axis. Okay? So solid line and we shaded below the actual line. Okay? This would be above the line. This is below the line. See how that works? Okay. All right. So then the case is, well, what's this dotted line about, and how do we know when to use it? Well, shading above is still going to work the same way. Okay, so we're going to go that way. And if it's not the or equals to thing, if it's just greater than, we use a dotted line, and I'll show you what that means. And then the same thing down here. If it's y is less than, we use a dotted line, and we shade below. So we're going to do some examples of each kind of those as we move forward. Let's do one right now. Okay? So y is greater than -1/3 x plus 4. So we're going to graph the same way. Okay, we go begin at the 4, that's my intercept. Slope is -1/3, so we're going to go down 1 and over 1, 2, 3. And again, we're just counting the boxes. And then, because it's not or equal to, we're going to use the dotted line tool. Okay, and you can just make a dotted line yourself. See how I did? Not half bad, I guess. Probably fudge that a little. Let's see if I can. There we go. That's better, I guess. Something like that. Okay? All right, so just a dotted line, because what it means in this situation means that the answer is not really on the line anymore. Okay? The answer is y is greater than -1/3 x plus 4. So we're looking at all the area above that line. So we're going to shade in, and again, shading in with just lines perpendicular to the boundary. Okay? So anything that's up here is where y is greater than -1/3 of x plus 4. So, if we picked just a random point, we plugged it in, we'd find that it was true. Okay? Y is greater than -1/3 x plus 4. So going back to the table, we've got greater than, we shade above. And since it's just greater than, we use a dotted line. Okay, and I didn't put the double-headed arrow in there. So y is greater than negative 1/3 x plus 4. That's how it works. Okay? Here's one. Y is less than 2x plus 2. So we know how to do this. Okay, we start with 2. That's where we begin. We go up 2. We go over 1. Because remember, slope of a whole number is like that. So up 1, 2, over 1. And again, boxes, going up 4 and over 2, that's the same thing. It's this kind, so we're going to use a dotted line. Get out the old dotted line tool, which apparently I have. And let's see if I can make this work. If I start about there, that's pretty good. That works for me. In terms of the shading, less than, so we're below the line. Okay, so below the line. Works better when you make a funny noise, so there you go. See, that wasn't nearly as much fun. This would extend all the way down here. I didn't extend it that far. Ooh. Probably can though, right? There we go. Into the funny noises. Alright, so that's it. All of this area over here is where y is less than 2 times x plus 2. Okay? Alright, that's how it works out. Dotted line because it's just less than, and shading below because it's less than. Okay, below, less than, above, greater than. See how that works? All right, last one of these, and then we'll just talk slightly about a different alternative way. Negative y is greater than or equal to negative 2x plus 6. You want to pause and try to do this yourself, and then join back in, and we'll do it together. This gives you a little time to just check your work. Okay? All right, welcome back. I don't know if you really paused or what happened, but we're going to go with it. So we should have it 6 right there. Okay, that's our beginning point. And we're going to go down 2 and over 1. Okay, I know some of you like to keep going down 2 and over 1 and down 2 over 1. You can do that if you really like to. We doing a dotted line or a solid line? That's correct. It's solid line. And so solid line's going to start right there. It's going to go there. It's going to go there. It's going to go about like that. Okay? Great. Shading, above or below? That's right, above. Okay, shading above. And we've got it. Okay, all this area up here is my answer, and it can be actually on the line, okay, because we're at the or equal to. So the line and any of the region that we shaded in above. I was being really careful, I get as close to that as I possibly can, but this gives us the general idea of what's going on, okay? So that's it. It's like graphing in slope-intercept form, except for we have to remember we're at dotted or solid and other for the shade. All right, so what if we're in this form here, that standard form that we've been working with? Okay, we do the old cover-up method to get our x and our y-intercept just like we did before. Cover-up method, so let's get the y-intercept first. Pretend I'm covering that up and you can't see it. That means my y-intercept is 2. Y-intercept 2. Okay, pretend we're covering this up. My x-intercept is 4. X-intercept is 4. So I've got the 2 points. Since this is r equal, we're going to go with a solid line. So nothing really has changed that way. About there, we'll start it. Should get close to where I want to be. That's nice. Nice. All right, and then the shading. Okay, so with the shading this time, because it's less, it's hard really to necessarily tell where we're going above, below, because it's not in that same form. So the easiest thing to do is to check 0. Okay, check to see if the origin's there. Okay, 0, 0. So if x is 0, I get 0 plus 0. Less than 12. Is that true that 0 plus 0 is less than 12? It is. 0 plus 0 is less than 12, so we know that this works, this point works, so that means all of the points down here work, so it turns out we are shading below the line with the less than, but just when it's in standard form, it's easier to just check 0, 0 to make sure, because, the different slopes and things may throw us off, so I don't want to have us make a general rule. Okay? That's it. All right, well, it's almost it. This is it, I swear. Same thing, cover-up method. I get my x-intercept to be 4. Well, let's put back up back. My y-intercept is -2. Like that. It's a just greater than sort of situation, so we're going to use the old dotted line tool. And going to start about there. Sure. Yeah, that's nice. That's very nice. Okay. All right. So again, we'll check out with the 0, 0 thing, what goes on when we plug 0 plus 0 in there. So 0, if I go 0 minus 0, 2 times 0 is 0, 4 times 0 is 0. 0 minus 0, is that bigger than 8? That's real lousy 8. 0 minus 0 is 0. Is 0 bigger than 8? No. So, in this case, this isn't the answer. So the answer shows up down here where 0 isn't. And so that's where we're saying we don't want to just automatically go greater than shade above in this case. Okay? So we just have to check 0, 0. So check 0, comma 0 to see if it works. Alright, so we've learned much, we hope. But we haven't learned much at all because graphing lines, graphing these is just using the stuff that we've been doing for graphing, just throwing the extra twist of where do we shade. So, that's my whole story for today. We will see you tomorrow. If you have questions, of course you should ask them. So, thanks for watching. Hope you learned something. We'll see you then. Bye-bye.